Greetings. Here we discuss section 5.3 and section 5.4 of the module 5 of the course MA202 Probability Distributions, Transforms and Numerical Methods. Module 5 Numerical Methods. Section 5.3 Interpolation of Equal Intervals. In this lecture, the contents are interpolation and finite difference operator, Newton's forward and backward interpolation formula, some solved problems. Interpolation. Let f of x be a function, and we know the values of f of x for some discrete values of x equal to x0, x1, xn. Then the process of finding the values of f of x for any value of x in the interval x0, xn is called interpolation, and the same process for any value of x outside the interval x0, xn is called extrapolation. For example, consider the following data set. Here, x assume the values 1, 2, 3 and 4. The range of this interval is 1, 4. And the corresponding y is equal to f of x values are 10, 24.5, 30 and 35. Here, the process of finding the value of f of x at x equal to 2.5, which is in the interval 1, 4. Therefore, this process is called interpolation. Then, the process of finding the value of f of x at x equal to 5, which is outside the interval 1, 4. Therefore, this process is called extrapolation. The next topic is forward difference operator. Consider the following table for the function y is equal to f of x. Here, x assumes the values x0, x1 which is equal to x0 plus h, x2 equal to x0 plus 2h, x3 equal to x0 plus 3h and go on. And the corresponding y values are y0, y1, y2, y3, etc. The main observation from this table are: the first one, the difference between two consecutive x values are same. Therefore, we can say that the values of x are equally spaced, and the difference between two consecutive terms is equal to h, which is called the interval of differencing. Then, going to the next definition, the first forward difference y0 is denoted and defined as delta y0 is equal to y1 minus y0, that is the difference between two consecutive y terms. Check the positions. Similarly, delta y1 is equal to y2 minus y1. In general, delta yn is equal to yn plus 1 minus yn. The difference of the first forward differences are called second forward difference. That is, del square of y0 is equal to del of del y0. That is equal to del within bracket y1 minus y0. Operate the bracket, that is equal to del y1 minus del y0. In general, del square of yn is equal to del yn plus 1 minus del yn. This section explains the construction of forward difference table. The values of x and the corresponding y values are given. Here, the x values are x0, x1, etc. up to x5, and the corresponding y values are y0, y1, etc. up to y5. Then the next column is del y, which is equal to first forward difference. The first element in that column is delta y0, which is defined as y1 minus y0. And we write the value of del y0 between y0 and y1 in delta y column. Then the second term in the del y column is del y1, which is defined as y2 minus y1, which is right between y2 and y1 in delta y column. Similarly, delta y2 can be defined as y3 minus y2, delta y3 is equal to y4 minus y3, and delta y4 is equal to y5 minus y4. Then the second ordered finite difference del square y column, we written a first element is del square y0, which is equal to the difference or del y1 minus del y0, which is placed between del y0 and del y1. And the second element is del square y1, which is equal to del y2 minus del y1, and so on. And we can fill the same way all other columns. Next section is Newton's forward interpolation formula. Interpolation is the process of finding the value of f of x for any value of x in the interval. The Newton's forward interpolation formula is defined as f of x equals y0 plus n into del y0 plus n into n minus 1 by 2 factorial del square y0 plus n into n minus 1 into n minus 2 divided by 3 factorial del raised to 3 y0 plus etc. where x equal to x0 plus nh, where h is the interval of differencing, and convenience we choose x0 as the first given x values. Then the question is, when we use Newton's forward interpolation formula, if the required x value is near the beginning of x values, then we use Newton's forward interpolation formula. From the problem part, we can easily access this statement. For the first example, using Newton's forward interpolation formula, find y at x equal to 8 from the following table. Analyze the question first. We want to find out the value of y at x equal to 8. From the table, the range of x values are 0 to 25. X equal to 8 is near the beginning of x values. The 8 is near to the beginning of x values. Therefore, we use here Newton's forward interpolation formula. Here x values are 0, 5, 10, 15, 20, 25, and the corresponding y values are 7, 11, 14, 18, 24, 32. I repeat, here we want to find out the value of y at x equal to 8. The value x equal to 8 is very near to the beginning of x values. Here, we are applying Newton's forward interpolation formula. From the given data, x0 is equal to the first given value of x, which is equal to 0 here, and the x values are equally spaced. That is, the difference between two consecutive terms are same. Therefore, that difference is called h. Here h is equal to 5. And x equal to x0 plus nh. Here x equal to 8. Therefore, substituting the values in the formula, 8 is equal to 0 plus n we don't know. We write same, h is equal to 5. Therefore, 8 is equal to 0 plus 5n. That is implies n is equal to 8 by 5, which is equal to 1.6. Then, the following is the forward difference table. First column we write the x values and the second column we write y values. Then third column del y or first forward difference. The first forward difference, the first element is del y naught, which is defined as y1 minus y naught. That is 11 minus 7, the value is 4, which is right in the del y column between 11 and 7. Then del y1, which is the difference between 14 and 11, that is 14 minus 11, 3, which is right between 14 and 11. The next is 18 minus 14, 4, which is right between 18 and 14. And the next is 24 minus 18, 6. Next is 32 minus 24, that is 8. Next column is del square y, which is the difference between 3 and 4, that is equal to minus 1, which is right between the 3 and 4. Then next is the difference is 4 minus 3, 1. The next difference is 6 minus 4, 2. Then 8 minus 6, 2. Then del cube y, 1 minus minus 1, that is 2. The next one is 2 minus 1, 1. The next is 2 minus 2, 0. Then del power 4y is equal to 1 minus 2 minus 1. Next 0 minus 1 minus 1. Then del raised to 5y is equal to minus 1 minus minus 1. The value should be 0. In that table, we mark the required values, that is y naught, del y naught, del square y naught, del raised to 3y naught, del raised to 4y naught, and del raised to 5y naught. These values are needed in the formula. Therefore, we mark bold. Newton's forward interpolation formula f of x equals y naught plus n del y naught plus n into n minus 1 by 2 factorial del square y naught plus n into n minus 1 into n minus 2 by 3 factorial del raised to 3 y naught plus n into n minus 1 into n minus 2 into n minus 3 by 4 factorial del raised to 4 y naught plus etc. Because the above difference table contains fourth order differences. Therefore, we write up to the fourth term. Then substitute the values, that is f of 8 is equal to the value of y naught is equal to 7 plus n 1.6 into del y naught, that is equal to 4 plus next term n 1.6 into n minus 1, that is 0.6 divided by 2 factorial 2 del square y naught. From the table it is minus 1 plus n value 1.6, n minus 1.6, n minus 2 minus 0.4 divided by 3 factorial 6 del raised to 3 y naught 2 from the table plus n 1.6, n minus 1.6, n minus 2 minus 0.4, n minus 3 minus 1.4 divided by 4 factorial, that is 24 into del raised to 4 minus 1 from the table. The values calculate using calculator. The value is equal to 12.77. Next example, given sine 45 is equal to 0.7071, sine 50 is equal to 0.7660, sine 55 is equal to 0.8192, and sine 60 is equal to 0.8660. Find sine 52 using Newton's forward interpolation formula. Here, the values, the function y is equal to f of x is y is equal to sine x. X values are sine 45, 50, 55 and 60. We have to find out the value of sine 52 using Newton's interpolation formula. Therefore, we consider this 52 is very near to the starting value of x. Here we have to find out y is equal to sine x at x equal to 52. Applying Newton's forward interpolation formula, here x naught is equal to 45 and h, interval of difference, is equal to 5. Therefore, x equal to x naught plus nh. Substituting the values, 52 is equal to 45 plus 5n. Therefore, n is equal to 7 by 5. Answer is 1.4. Then we construct the forward difference table of the above problem. The x and y values are given. Then we write del y, the third column, which is the difference of y1 minus y0 is the first term. That is 0.0589. Next is del y1, that is 0.8192 minus 0.7660, that is equal to 0.0532. Next is 0.0468. The next column is del square y, which is the difference of 0.0532 minus 0.0589. That is equal to minus 0.0057. Similarly, the next term is minus 0.0064. Then the third term, del raised to 3y is equal to the difference between minus 0.0064 minus 0.0057, that is equal to minus 0.0007. Using Newton's forward interpolation formula, f of x equal to y0 plus n into del y0 plus n into n minus 1 by del square y0 plus n into n minus 1 into n minus 2 by 3 factorial del raised to 3 y0. We have to find out the value of f of x at x equal to 52. Substituting the values, y0 is equal to 0.7071 plus n we got it as 1.4 into del y0, the value is 0.0589 plus n 1.4, n minus 1.4 by 2 factorial, that is 2, del square y0 minus 0.0057 plus n 1.4, n minus 1.4, n minus 2 minus 0.6 by 6 into del raised to 3 minus 0.007. Calculating these values, we got 0.7880. The next topic is backward difference operator. Backward difference operator is denoted and defined as inverted delta. For convenience, I call del y1 is equal to y1 minus y0. That is the difference of y1 and just back value of y1. In general, del yn is equal to yn minus yn minus 1. Next, Newton's backward interpolation formula. F of x equal to yn minus n del yn plus n into n minus 1 by 2 factorial del square yn minus n into n minus 1 into n minus 2 by 3 factorial del cube by n plus etc. where x equal to xn minus nh, where xn is the last given value of x in the table, h is the interval of difference. Then the question is, when we applying this formula, if the required x value is near the nth x values, then we use the Newton's backward interpolation formula. The first example, the following table gives the population of a town during the last census. Estimate using Newton's interpolation formula the population during the period 1948. The given data is, first of all, year 1911, 1921, 1931, 1941, 1951, 1961. Population 12, 15, 20, 27, 39, 52. The question is, calculate the population during the period in 1948. The value of x equal to here 1948, which is near to the nth value of given x, 1948. Therefore, we apply Newton's backward interpolation formula. On the given data xn, the last given value of x, that is equal to 1961, h is equal to interval of difference, that is equal to 10, and applying the result x equal to xn minus nh, and substitute the values where x equal to 1948, that is equal to xn 1961 minus n we don't know, h is equal to 10. Then we can easily calculate the value of n is equal to 13 by 10, that is equal to 1.3. Then the following table explains the construction of backward difference table. It is exactly same as the construction of forward difference table, only difference in notations. The first two columns we mark x and y values which are given from the question, which is given in the question. The second column is del y, the first backward difference. The first backward difference is del y1, that is equal to y1 minus y0, that is 15 minus 12, which is marked between 15 and 12 in del y column. The next is 20 minus 50, that is equal to 5. 27 minus 20, it is 7. 39 minus 27, 12. 52 minus 39, 13. And the backward differences del square y, del cube y, and del raised to 4y and del raised to 5y can be constructed similarly. By Newton's forward interpolation formula, f of x equals yn minus n into del yn plus n into n minus 1 by 2 factorial del square yn minus n into n minus 1 into n minus 2 by 3 factorial del raised to 3 yn plus n into n minus 1 into n minus 2 into n minus 3 by 4 factorial del raised to 4 yn minus n into n minus 1 into n minus 2 into n minus 3 into n minus 4 by 5 factorial del raised to 5 yn. Here I used the fifth power of backward difference operator because the last table we can construct the fifth ordered backward difference. Therefore, I add the fifth power term in the formula. Then f of 1948 is equal to, substitute the values, yn the 52 minus n 1.3 into del yn 13 plus n 1.3 n minus 1.3 by 2 factorial, that is 2 into del square yn, it is 1 minus 1.3 into 0.3 into minus 0.7 by 6 into minus 4 plus 1.3 0.3 minus 0.7 into minus 1.7 by 24 into minus 7 minus 1.3 0.3 minus 7 minus 1.7 minus 2.7 by 120 into minus 10. Calculating, we got the final result as 34.913. Example 2. Form the difference table of f of x equal to x raised to 3 minus 3x square plus 5x plus 7 for the values of 0, 2, 4, 6, 8 and find the value of f of 10. Here the given function is f of x equal to x raised to 3 minus 3x square plus 5x plus 7. Also, we want to find out the value of f of x at equally spaced values of x equal to 0, 2, 4, 6, 8. Directly substitute the values for x equal to 0, 2, 4, 6 and 8. We got the values. That is f of 0. Put x equal to 0 in the given function. We got 7. F of 2. Substitute x equal to 2 in the given function. We got 13. F of 4. Put x equal to 4. We got it is equal to 4. F of 6. That is equal to 145. F of 8, we got it as 367. Here we have to the question is to find the value of f of 10. That is, the 10 is very near to the n values of x. Therefore, we apply Newton's backward interpolation formula. From the given data, xn is equal to 8, h interval of difference is equal to 2, and using the result x equal to xn minus nh, that is 10 is equal to 8 minus 2n. Find out the values, that is equal to n is equal to minus 1. Then the following table is the construction of backward differences. First two columns mark x and f of x values. Then the backward difference 13 minus 7, 6, 43 minus 13, 30, 145 minus 43, 102, 367 minus 145, 222. Then del square y, del cube y and del raised to 4y same as the last table. By Newton's backward interpolation formula, f of x equal to yn minus n del yn plus n into n minus 1 by 2 factorial del square yn minus n into n minus 1 into n minus 2 by 3 factorial del raised to 3 yn plus n into n minus 1 into n minus 2 into n minus 3 by 4 factorial del raised to 4 yn. F of 10 is equal to, substitute the values, yn 367 minus n minus 1 into del yn, that is 222, plus n minus 1 is minus 2, divided by 2 factorial is 2, del square yn 120 from the table, minus 1 into minus 2 into minus 3 divided by 6 into del raised to 4yn, it is 48. Calculating these values, 367 plus 222 plus 120 plus 48, that is equal to 757. Section 5.4, Lagrange's formula for unequal intervals. Let y is equal to f of x be a function which take the values y0, y1 dot dot yn when x assumes the values x0, x1 dot dot xn respectively. If the values of x are not equally spaced, we applying Lagrange's formula for unequal intervals. The formula is stated as follows: f of x equal to y0 into x minus x1 into x minus x2 into x minus x3 etc. into x minus xn divided by x0 minus x1, x0 minus x2, x0 minus x3 dot dot x0 minus xn plus y1 into x minus x0, x minus x2, x minus x3 etc. into x minus xn divided by x1 minus x0, x1 minus x2, x1 minus x3 etc. x1 minus xn etc. plus the last term yn into x minus x0, x minus xn, x minus x2 dot dot x minus xn minus 1 divided by xn minus x0 into xn minus x1 into xn minus x2 dot dot xn minus xn minus 1. Check the first term in the formula. There is y0 into a p by q form. In the numerator, there is no term of x0. That is x minus x1, x minus x2, x minus x3 dot dot x minus xn. In denominator term, we replace x by x0. That is x0 minus x1, x0 minus x2, x0 minus x3 dot dot x0 minus xn. Check the second term plus y1. There is no x1 term in numerator, and in denominator we replace all terms of x by x1. That is x1 minus x0, x1 minus x2, x1 minus x3 dot dot x1 minus xn. Same as all other terms. Example 1. Using Lagrange's formula, find the value of y when x equal to 10 from the following data. The data set is x values are 5, 6, 9, 11, y 12, 13, 14 and 16. Observe the x values which are not equally spaced. That means the difference between two consecutive values of x are not same. From the data, we can easily write x0 is equal to 5, x1 equal to 6, x2 is equal to 9 and x3 is equal to 11 and y0 is equal to 12, y1 is equal to 13 and y2 is equal to 14 and y3 is equal to 16. There are 4 x values and the corresponding y values. Then we applying Lagrange's formula. Applying Lagrange's formula for the terms y0, y1, y2 and y3, we write y of x equals x minus x1 into x minus x2 into x minus x3 divided by x0 minus x1 into x0 minus x2 into x0 minus x3 into y0 plus dot dot dot. The last term is x minus x0 into x minus x1 into x minus x2 divided by x3 minus x0 into x3 minus x1 into x3 minus x2 y3. In the above formula, we substitute the value of x equal to 10 and the x0, x1, x2 and y1, y2, y0, y1, y2 and y3 are from the given table. Therefore, we got the values of y of 10 is equal to 4 into 1 into minus 1 divided by minus 1 into minus 4 into minus 6 into 12 plus 5 into 1 into minus 1 divided by 1 into minus 3 into minus 5 of 13 plus 5 into 4 into minus 1 divided by 4 into 3 into minus 2 of 14 plus 5 into 4 into 1 divided by 6 into 5 into 2 of 16. Finally, calculating this one, we got y of 10 is equal to 14.67. Example 2. Using Lagrange's formula, fit a polynomial for the following data. Hence, find the value of y at x equal to 2. The x and y values are given 0, 1, 3, 4 and the corresponding y values are minus 12, 0, 6, 12. The question is to fit a polynomial or find a polynomial corresponding to the data set. Here x values are not equally spaced, therefore we can apply Lagrange's formula. The solution is, first of all we write x0, x1, x2 and x3 which are 0, 1, 3 and 4 and y0 is equal to minus 12, y1 equal to 0, y2 is equal to 6 and y3 is equal to 12. Then by applying Lagrange's formula, write the Lagrange's formula for the terms y0, y1, y2 and y3, that is y is equal to f of x equal to x minus x1 into x minus x2 into x minus x3 divided by x0 minus x1 into x0 minus x2 into x0 minus x3 into y0 plus etc. the last term plus x minus x0 into x minus x1 into x minus x2 divided by x3 minus x0, x3 minus x1, x3 minus x2 into y3. Here our objective is to calculate a polynomial. Therefore, we keep x as same. That is y is equal to x minus 1 into x minus 3 into x minus 4 by minus 12 into minus 12. In second term, one term is 0. Therefore, we can neglect x into x minus 1 into x minus 4 by minus 6 into 6 plus x into x minus 1 into x minus 3 by 12 into 12. Therefore, we rearranging and calculating these values, we got a polynomial f of x equals x raised to 3 minus 7x square plus 18x minus 12, which is the required polynomial. One of the point we observed, if you are given a 4 set of values, that is x0, x1, x2, x3 and the corresponding 4 y values, but the polynomial degree is third degree. That is, you are given a data set or n data set, we can construct a polynomial of degree n minus 1. One more additional question, that is f of x equal to x raised to 3 minus 7x square plus 18x minus 12. In the question, hence calculate the value of f at x equal to 2. Then you directly substitute x equal to 2. That is f of 2 is equal to 2 raised to 3 minus 7 into 2 square plus 18 into 2 minus 12. Calculating and rearrange, f of 2 is equal to 4. The next section is exercise. Here four problems are given. These questions are from the previous university question paper 2018 and 19. Try to solve these questions. For any clarifications or doubt, feel free contact us through mails, WhatsApp or direct phone calls. Stay safe and stay home. Thank you all.